Thank you, everyone. Thank you, Moise, for the introduction. So, I'm Waqar Saleem. I'll be talking to you today about my adventures of code, and you'll see in a minute why it's named this way. Fair warning, this presentation, I'll be switching quite a lot between the slides and the browser and my editor. The presentation may seem a bit hacky, but this is PyCon, so I suppose that's all right. I'll be presenting some code which will not be following best practices, but I hope that we'll still be fine with that. I'll primarily be talking about something called Advent of Code. We've already heard today about Santa Claus. We have heard about games. Sundar STEM is also here, so we know about competitive programming. This is going to put them all together in a nice, fun way. But enough about that. Let's talk about more interesting things. Let's talk about me. I'm Waqar Saleem. As I said, I'm an associate professor of computer science at Habib University. My baggy pants will tell you that I'm a little behind on fashion trends, but that's okay. My redeeming quality is that I like Python. And I like it so much, I made a video about it, which I'll make you watch now. If it works.
Hi, I am Waqar Saleem from the Computer Science program at Habib University. At Habib University, we use Python as the first programming language. We use Python because it's simple. It's powerful. It's beautiful. Come see me at PyCon, where I will talk more about our affair with Python.
Right, so I was very excited about Python. I was very happy when PyCon started in 2017, so I immediately jumped on it, and it's amazing what you can make students do when you control their grade, as you saw. So they were more than happy to make the video. I've spent about 10 years in Germany, and you may know Germany for its Kartoffelsalat or the Lederhosen. They like their Fußball over there. They also make nice cars. But one of my favorite things, which is also somewhat surprising to many people, is that Germany is where the doner kebab was born. More relevant to this talk, in Germany I got introduced to what they call the Adventskalender. The Adventskalender is a calendar like this. It has doors or windows, however you call them, for each day of December, starting from December 1st to December 25th. It's meant mostly for kids, so they're like fun graphics. It's Christmas themed. The numbers are not in order, so you have to search where's the 1, where's the 2. So here the door for 1's already open. The idea is that on the 1st of December, the kid goes excitedly to their advents calendar. They open the door for December 1st, and out comes the chocolate. And they do the same for December 2nd. December 2nd is not next to December 1st. Can anyone see where number 2 is? It's not very visible. Number 2 is here, so on December 2nd, you go, you open that door, you get the chocolate, and so on until 25th of December. Good. In fact, interestingly, just this year, I started seeing something similar for Ramzan as well. That may be relevant considering we may be starting with that tomorrow or the day after. So why are we talking about calendars here at PyCon? Because my talk is going to be about a similar calendar of sorts. But the goodies here are not chocolates, they're even better. They are programming puzzles. And you have here this website called Advent of Code. Here you see it's not called completely in order. There's a row corresponding to the 1st of December, row corresponding to 2nd, 3rd, 4th, 5th, 6th, 7th, and so on. Altogether, they make 25 days. And actually, this is a bit filled up because I started my Advent calendar. My Advent calendar in the beginning was completely blank. So you have just pretty much a blank page. It's online. It's at adventofcode.com. You start off with this blank page. On December 1st, the first puzzle becomes available on the website. Each puzzle is in 2 parts. The first part is kind of the setup, so that you get used to the story and how to parse the data and so on. And the second part is a twist on that. Maybe they change the requirements or they change the interpretation of the input and so on. Every time you do a half of the puzzle, you get a star. So if you complete all of day 1's puzzle, then you get 2 stars, then you get 2 stars for day 2 and so on. By the end, you have 50 stars. I don't have them yet. So you would end up with something like this. And as you get more stars, the calendar fills up, and then there's some animations and so on, and it's kind of cool. I made up to 35 stars. As you can see, some days I have no stars. It was either some problems are quite hard, or I ran out of time. Most days I had a couple of stars. Some days I have only 1 star. And as you get the stars, then this calendar fills up, and it's interesting. So seeing that I was not able to get the 50 stars, I was quite upset because I'm this associate professor. I should be knowing all this stuff. So I said, okay, I did what most academics do. I said, let's go to the source. So this was 2023, just 3 months ago. So the very first advent of code took place in 2015. I hunted the website. I found the very first advent of code. So I said, okay, let us try the very first advent of code. So when you go to the website, they have this nice animation. Again, you see there all these days, they're more linear at that time, going up from day 1 to day 25. It's currently blank. There's just this nice animation playing. But I was able to do better at this. Most of them have 2 stars. I think I'm missing just 1, 2, 3 stars. I should be up to 50. So that's how it goes. This was good because this happened during winter break. We had about a week and a half off from university. Exam that just finished. My kids were on holiday and I ignored them the entire 1.5 weeks doing these 25 puzzles. So I guess they're happy that this came to an end. I do plan to work my way up to 2016, 17, 18, all the way to 2023. We'll see how that goes. Hopefully I don't get a divorce. But what we'll now do is that we look at some of the puzzles. What do these puzzles look like? So these puzzles are 2-part puzzles. They're all Christmas themed. It's Advent calendar. It's December. It's a season of being joyful and merry. Part 1 of the puzzle is some basic setup. Part 1 is the only thing you see when you load that page, and at the bottom of the page is a text field. Part 1 presents some problem. You have to solve that problem. It links to some input, so you read that input, you solve the problem, and then you enter the solution to the problem into that text field. If the problem is correct, then part 2 unlocks. Otherwise, it tells you the answer is wrong. Please try again. Part 2 is usually some twist on part 1. Part 1 is relatively simple. Part 2 then gets things more complicated. So you get 2 stars for the full problem. Then you move on to the next problem and to the next problem. Your advent calendar fills up as you get more stars, and if you solve all 25 problems, you get 50 stars. Hooray! You can feel happier about your life. So let's look at some of these problems. What do they look like? I got the most progress in 2015, so I'll be going over some problems from 2015 just to give you an idea of what they look like. And then why this was interesting to me, so in that time when I was solving those advent of code problems, I had a great time. Because this was more of a leisure activity, I was doing this for fun. It was not for work. It was not for any competition. This was just fun. So there were a lot of things that I was curious about in Python. There were features that I had read about or known about but hadn't really got to try. So this was a nice testing ground for me to do all that stuff. So I was having a lot of fun around that time. PyCon's call for proposals came up, so I said, okay, let's see if people will be interested. Turns out that they were. I'm here. So hopefully you will also find this interesting. Okay, let's look at day 1. What does that look like? Day 1 is here. You'll probably not see. Hang on, let me. So I'll give you some time to go over this just so that you get used to the setup. I won't go over every problem in so much detail, but here we can take some time to go over the problem just so that you become familiar with this setup. Is the text fine? Can we read this? So I don't know how far down you are. There's a lot of story, as there usually is in such problems. The main computation problem is basically starts around here. We have a string as input. The string contains open parentheses and closing parentheses, and opening parentheses means that you go up 1 floor, or closing parentheses means you go down 1 floor. You start at floor 0, you read the entire input, you tell at what floor do you end up. And here are some examples to illustrate. So here you go up 2 floors, come down 2 floors. That would result in floor 0 because you start at floor 0, go up 2, go down 2, end up at floor 0. Here, go up 1, go down 1, go up 1, go down 1, again end up at floor 0, and so on. And they also give a link to the puzzle input. Puzzle input is going to be a bunch of larger strings. So this is not all that complicated. So I have already solved the puzzle, so it shows what the answer is. If I had not solved it, then this would be actually no here part. This would be blank. I'd have to enter my answer here, processing that input, and then if my answer is correct, then part 2 would unlock. So I've already done this. So part 2 is unlocked. Part 2 is a slight variation. In part 2, we have the same input, so that's important. Part 2 uses the same input, but now the problem is slightly tweaked. So in this case, we have to tell what do we have to tell? The position of the first character that causes him to enter the basement, floor -1. So at what character do we enter floor -1? So this, of course, you also give input in the same way. There's usually a blank text field here. You enter your answer, and then for the input that's provided, and then if you get it right, then you get your 2 stars. So this is straightforward. Nothing too complicated here. This is day 1. This is day 1. So there's a bunch of skeleton code that you can ignore. So part A is straightforward. Just look at. Sorry. Just look at what am I doing? Turn it disabled. Right. Just look at the parentheses. If you see an open parenthesis, add 1 for negative. For otherwise, add -1, and you return the sum for that. Part 2 is similar. Just look at when does the floor become -1, and then you return the index at which the floor becomes -1. So here, the main idea here was to get you used to the setup. How are the problems presented in 2 parts, and how do you go about solving them? I'll go through a couple of other problems that I found interesting in that they allowed me to explore some features of Python that I was generally curious about. I should add that I've spent some time with Haskell. Haskell is a functional programming language. I like the functional style a lot. I think it's very expressive. It's very powerful. And most of my adventures with Python in this context were in finding out how I can do functional style programming in Python. And I was able to find good support for that in Python. Okay. Where is my presentation? Here. Right, so this is day 1. What floor do we end up? This is day 2, day 1, part 2, which is at what index do we enter the basement? I'll go over about 5 more problems. The next one is from day 2. Day 2, the problem was relatively straightforward. It was some geometric problem. Santa has some gift boxes. They're in the shape of cubes. We have to figure out, I think, the minimum area, minimum volume, maximum volume, so something like that. I forget exactly. You have to pack the cubes into a sleigh. So the interesting thing here was, so the input was in this form: length times width times height. It was a whole bunch of text. And so things like this, I can of course just input the string, parse the string, but I thought no, Python probably has something better. Usually something like regex would come to mind here. Regex is great. I found another package called parse. I'm not sure if people know about this. I was very happy to find out about parse. I call parse regex for the week. Parse is pretty good for most text parsing. So if you define some pattern, it will parse the text, give you the values of the variables. So I use parse, I get the values, and I do some stuff with the values. That's not really important here. But what I want to emphasize here is that I use this problem as a launching pad to go and find some useful Python module for parsing text, and I found this module called parse, which was very useful in later problems as well. Many other problems required me to read text in a structured format and extract data from that. Day 5 was interesting. Let me go to the problem. Day 5. So once again, there's a whole bunch of story, but the interesting part for us is basically this. We are given some strings and we have to categorize if the string is nice or not. And a nice string is defined as containing at least 3 vowels. It contains at least 1 letter that appears twice in a row, so a repeated letter, and it does not contain some particular pairs. And then there are some examples. So we are given a bunch of strings. We have to basically tell if a string is nice or not. Nice is defined in this manner. So essentially, computationally, what we have to do there is that we have to figure out, given a string, does it contain at least 3 vowels, and we have to iterate over pairs of letters in the string. This is not too complicated, and my default approach would be to maybe I can take the string, filter all the vowels, and then see how many vowels have I counted. But then I thought, my string may be very long. Why do I need to count more vowels than 3 if I'm only interested in 3 vowels? So maybe I can keep a running counter. I start a counter at 0, Every time I see a vowel, I up it by 1, and then when my counter hits 3, I say, good, we are at 3 vowels. But I thought like that's too much work. There must be something that Python can do natively, and then I was able to find something. I'll show that. For the consecutive letters, the default way to go about that would be to zip the string and a slice of the string starting one after. But here again, I was able to find something that made this thing into a more elegant solution, which was this. So I found this method called iSlice in itertools. I don't know how many people are aware of this. So iSlice is very nice because iSlice takes an iterable, and then you can define that however you want. And you tell iSlice that I want only these many. And then when iSlice finds these many, then it'll stop. So it is not that I'm going to go over the entire string to find all the vowels. iSlice itself will take care of stopping once it finds the 3 vowels. So I don't need to maintain a counter. I don't need to count all the vowels. iSlice is going to do the work for me. I also found, also in other tools, this function called pairwise that I found very nice. Pairwise does exactly what this shows here. Where did it go? Pairwise does exactly this. Maybe it's syntactic sugar, but it's nicer to type. It's cleaner and more elegant. So I found this. So that was nice. Day 7, there was something interesting there. Day 7, again, there's a lot of story which we can ignore for now. Essentially, day 7 was for input. We had here a bunch of some instructions. It's kind of like assembly. The symbols have certain meaning. We have these symbols are self-explanatory. If you see an and, that means that we want to do a logical and on the bitwise and on the operators. And there's bitwise or, left shift, right shift, negation, and so on. So here, there was nothing really too fancy from Python that I had to use, but I just thought it pretty cool that I was able to, this was day 7. Day 7. So I found it quite nice that I could just define a dictionary with 6 anonymous functions. If you've programmed in other languages, then good luck with the syntax of doing this. But this I found pretty neat. Then parsing the string was not that complicated, but it was nice that I had this dictionary. This just made parsing the string and applying the operations very, very convenient. So that was neat. Day 10, I have only 3 more, including this. This was interesting. So I was not aware of this. There's supposedly a game called Look and Say, and it originates to John Conway from Game of Life. So this game essentially generates a sequence. The first term in the sequence is a 1. Let me move this up. The first term in the sequence is 1, and the name of the game tells how the game is to be played. You look at what you have, and then you say it out. And what you say becomes the next term of the sequence. So for example, when you see this is always the first term. You say, I have 1, 1. So the next term is 1, 1. When you look at this, you say, I have 2 1s. So the next term of the sequence is 2 1s. If you have to say it out, you say, I have 1, 2, and 1, 1. So that becomes this, 1, 2, and 1, 1. If you say it out, you get the next term of the sequence, which would be 1, 1, 1, 2, 2 1s, which is this term here. If you have to say this one out, you get 3 1s, which here the 3 1s, 2 2s, 2 2s, 1 1, 1 1, and so on. So this was nice, and in here we basically had to tell, what did we have to tell? So we apply the process 40 times, and what is the length of the result? So one thing you can see is that the length of the term, the length of the string is increasing each time. So after 40 iterations, it becomes quite large. In fact, so this was the answer. There were these many characters in the result after 40 iterations of this. So so essentially what we have to do is that we have to detect runs in the string and the length of the run. So for example, this is the first term. It's a run of length 1 of character 1. This is a run of length 2 of character 1. This is a run of length 1 of character 2, run of length 1 of character 1, and so on. So you basically have to detect runs. Again, it's not difficult to code, but I looked for anything elegant that Python could provide, and indeed I came across, again, something in iter-tools. So iter-tools is my new favorite, in addition to func tools. iter-tools gave me group by. Group by does exactly what we wanted. It'll go over an iterable. I define the iterable. It's our string. So we go over the string, and group by is going to give us back essentially a dictionary of a character and the length of its run, then the next character and the length of its run, and so on. So that was neat. Day 12. This was nice. Again, there's some story which we can skip for now. We have some input. Let me show you what the input was like. The input is going to be, this was the previous one. The input is essentially some string in JSON format. We know it's a valid string. And what we want to do is that we want to parse that string and then sum up all the integers in that string. For example, if this is what the string is, then the integers here are 1, 2, and 3, and we want to return the sum 6. In this case, the integers are 1, 2, and 3. Sorry, this is part B. Hang on. Part A. Part B has a little twist, but part A is more straightforward. Here, 1, 2, and 3, the result is 6. 2 and 4, result is 6. 3, only 3, result is 3. In this case, 4 minus 1, result is 3, and so on. Minus 1 plus 1 gives 0. Minus 1 plus 1 gives 0. So we ignore all the other stuff, find the integers, and sum all the integers. Again, we could do this, not very difficult with regular string parsing. But one thing that I was very happy to find in Python, somehow I'd missed this, I wasn't aware of this, but then some Googling led me to it. Python has, maybe some of you know this already, but I was very pleasantly surprised to find this. Python has, the wrong window. Python has match case. Match case implements what we call structural pattern matching. We may be initially misled to think of it as C or C++. I think C doesn't have it. C++ has switch case. Switch case does matching based on the value of the variable only. Structural pattern matching is much more powerful. Structural matching is not going to match based on the value. It's going to match on the structure or the type. So here I'm matching based on the type. We can even match based on the structure. So here you see I'm matching some variable, and I'm doing different things based on the type of this variable. If it's an integer, I do something. If it's a list, I do something else. If it's a dictionary, I do something else, and so on. So this was pretty neat. Day 14, this is the last one for this presentation. Day 4, so you see we're about halfway through the month now. The problems are getting more complicated. This already is, this is the reindeer Olympics. Santa's having fun by now. He's racing his reindeers, and the input is going to be some data on the reindeers. As an example, we have data on the reindeer comet. Each reindeer has some characteristics. Namely, the reindeer can fly at a certain speed. Sorry. Handle le lo. I'll try and be loud. So each reindeer can fly at a certain speed for some time. So in this case, comet can fly at this speed for 10 seconds. Good, thank you. So comet can fly at this speed for 10 seconds, but after all that flight, comet gets tired, and comet has to rest for 127 seconds, and then that pattern repeats. Dancer can fly for 16 meters per second for 11 seconds, but then dancer gets tired, and dancer must rest for 16. Is this being cut out? For 162 seconds. And what we have to do, so our sample input contains data on several reindeer. What we have to do is that if this race, if all of these reindeer, they start at the same time, and the race goes on for these many seconds, then what distance has the winning reindeer traveled? This was part A. I want to show part B, which adds a twist to it. So here in part A, we only want to see that, okay, what's the result at the end of this time? Part B introduces a twist. Part B says that we're not interested not only at the result at the end of this time, rather we want to see at the end of every second who's winning. And then we want to add up all of those scores at the end of every second. So that's right. So each reindeer accumulates points based on its result at the end of every second. So this was interesting. Part A is not all that complicated, but part B introduces this twist that we now need the result at the end of every second. So here, what we need computationally, so the way I solved it is that first of all, every reindeer has a pattern of fly, rest, fly, rest, fly, rest. This is the same pattern repeats. So I need some way to repeat a pattern infinitely until a certain time. So that way I can figure out what's happening with the reindeer over my desired duration. And then I also need to know that over this duration, not only do I want to know what happens at the end, I want to know at every second what happens. So I need some way to accumulate what we can call a partial sum. So what's the distance that the reindeer has traveled at the end of second 1, and at the end of second 2, at the end of second 3, end of second 4. So all of those I call partial sums. And again, I found some nice tools in Python. I found this cycle. I don't know if it's visible here. Let me go to my editor. This was day 14. Right. So what I want to draw attention to is this part here. So there's let me hang on. So all of these, I believe, are also from iter tools. A cycle takes any iterable and it repeats that infinitely. Of course, you don't want to evaluate that; it's a lazy evaluation. So then you have to cut it at some point, and that we bring in our friend iSlice. iSlice is going to take only the first time number of elements from this infinite cycle and accumulate is a function that takes an iterable and then it gives you partial sums for every step of the iterable. So this was pretty neat. I was able to solve this in like four or 5 lines. So that was nice. Good. So after solving all these problems, I found out that Advent of Code is pretty popular. Someone has already written a package for Advent of Code, AOCD. This helps with basically fetching the input, submitting your answer, so you don't need to go to the website each time. This is just from some of my code here uses it. So here I import, and at the bottom I am right. I tell it what day and what year I'm interested in. I can get data as well, so I don't need to go to the website each time. And I can submit my result to the server, and it fetches the result from the server. That exists every year. There's a new subreddit created. The subreddit is a great place. You have these people all over the world who are solving these problems at the same time. There's lots of discussions. People share solutions. They're very creative visualizations. Many of these problems they can be nicely visualized, and many people spend a lot of time and effort making very interesting and funky visualizations. So that's a lot of fun to go into. The problems get harder. I've shown only till like half the month. As you go later in the month, then the problems cover things like pathfinding, optimization problems, maze traversal, flood fill, dynamic programming, cycle detection, collision detection, and so on. So you have to not only be correct, you also have to be efficient, because otherwise your computation can run the inputs get quite large. So your program could run for many hours, but then with the right algorithmic tweaks, you can do it in a couple of minutes. So that is a good payoff for your algorithmic optimization. So this website is run by a single person since 2015. He is also coming from a he's by profession, he's a software engineer, but he likes to teach. And he was already involved in several projects teaching, I think mostly children, about programming, not very different from what we saw this morning. So he somehow thought, hey, it was Christmas time. He was sitting, I think, somewhere in Boston. I think he's based in Boston or New York. I forget exactly. There's a few talks. He was sitting in some cafe. He thought, hey, why don't I put Advent calendar and Christmas and programming all together? So he put up this website 2015. And by now he has good corporate sponsors. So the 2023 iteration has big names as sponsors on the website. But he's running the whole thing on his own. He spends a lot of time coming up with these problems and all the other server issues. But he raises the problems at midnight his time. That's 10 p.m. here. That can be problematic because I'm coming back from work. I need to be fresh for the next day. I'd like to keep my day job as well, not spend all the time on this. So keeping up with all this was a bit hard for me. But generally, I liked how this provided me an avenue to explore things that I wanted to. Usually when one thinks of solving puzzles in a programming context, and one usually thinks of competitive programming, where people from Sundar STEM here, this is kind of a low-stress version of competitive programming. Competitive programming is very time-bound. You have to solve that problem in that amount of time. Here, there's no time-bound. There is some leaderboard, but it is not really recommended to pay attention to that leaderboard because that leaderboard fills out depending on, I think the first 20 days, the global leaderboard fills out within 5 minutes of releasing the problem because there's these hardcore competitive programmers who are just like waiting at midnight. But in the later days, day 20 to day 25, it takes about 20 minutes to fill up. But still, the maintainer himself, he says, don't worry about that. So it's really, the problems are available. So I was able to access in 2023, the problems for 2015. So they stay available. It doesn't care about how you solve the problem. You could solve it on paper if you want. And there are people on the subreddit who report solving the problems on paper. All it is interested in is that you submit the right problem. There's only one text field. So you could be efficient, you could be inefficient, you could use whatever language you want, you could solve the problems by hand, you could do it alone, you could do it with friends. And it's very, I found it very nice and refreshing after my exposure to competitive programming, which is a much more stressful environment. And you can make private leaderboards, so that's fun. I made one with my students, and I'm happy I was not the top one there, so one of my students did very well. So that's nice. You can make some private leaderboard with people who are in your time zone, and this is kind of a fun thing that you can talk to your friends about. And it'll be nice. So it happens only in December, which is some time away, but it'll be nice if some of us do Advent of Code. It's free. You don't need to sign up. Well, you need to log in with your account, Google or GitHub or so on, because it needs to remember your stats. What have you solved? It also gives you personalized input because, of course, if it's the same input for everyone, then people could just share solutions. So it gives you personalized. I think there are like many different versions of input. So it's not a unique input for every person, but there are many different versions, and then most likely you will have a different input than what your friend receives. But yeah, it'll be nice if we do an Advent of Code in December. You could add me to your leaderboard, and then that would be fun. That's pretty much it. So thank you, and I'm happy to take your thoughts, comments, questions.
It will be nice, but we can only take one question.
Thank you, that was a great talk. I just wanted to ask you about your choice of using Python as the first programming language. I mean, all the elegance that you showed, the beautiful libraries, they hide the underlying complexity. Don't you think it's an impediment for your students to kind of learn the internals because the algorithms are nicely cut away somewhere that you want them to do?
Right. So I would not want my first semester students to program like this. So this is so the students that I was on the leaderboard with, they're usually third or fourth year students who have hopefully good command on the fundamentals. So you're absolutely right. In the first programming course, we are much more lower level than this. Why not use? So that's a good question. There's a lot of debate within our program at the university as well. There's of course that C and C++ camp. I come from that camp myself. My own training is in C and C++ initially when I was a student. But I believe, and so far this argument has won out, that Python allows one to focus more on the problem than on the syntax. C and C++ maybe gives you a lower level understanding, and indeed we have people coming from systems especially who are very gung-ho, that know right from the very first semester, so they should know about memory, they should know about pointers. But so far, the argument that students should first know how to problem solve and get the language out of the way, that has won out, and I think Python allows a way to do that. You can get the language out of the way and focus on the problem. With C and C++, and probably people from system would disagree, but I think that with C and C++, there's complication not only of the problem, but also of the language that you have to take on.
Thank you so much for that.